Hey everyone, it's Mr. Aarons again. We're working on 4.2 homework today. If you did not watch that lesson yesterday, you need to make sure you do that. There's 2 parts to it. I know it's a little bit longer, but this is a huge lesson for us in showing this chapter. I'll give some ideas here, but I'm not going to be able to give up what that was 27-minute lesson was able to. So I'm going to do 3 examples from the homework today, and then I'll let you do the rest. All right, before we get started, I have a few things up here at the top. I have that y equals mx plus b formula that Ms. Pilney talked about yesterday. We have our common difference right here. That's our, if we're looking at these right here, that's going to be the difference between these. And then our b, remember, is what y is at 0. So, for example, when, or x is at 0, excuse me. So x is 0. What is y? This is worded really. It should be y at x is 0, is what it should really say. So when x is 0, y is what? That's what your b is going to be. It's also called the y-intercept, where our graph crosses y. All right, so we're looking at number 1 right away. I also have this over here. I put x, different words for it: input, independent; y, output, dependent. And we know that our x causes y, our independent causes are dependent. So number 1, they ask us for a few things. For each diagram, find the relationship between the number of shapes and the perimeter of the figure they form. Represent the relationship using a table, words, an equation, and a graph. So we've got quite a few steps here. So what we're going to start out by doing is creating a table. So right here, I'm going to have a 3-part table. My first one is going to be number of rectangles. There were some examples like this yesterday of rectangles. Number of rectangles, and then I'm going to have the perimeter. Our number of rectangles is also going to be our x. Perimeter is going to be our y. And my last one is I'm just going to do my OP, or my ordered pair, and that's going to be my set of my x and y. I should say y right here. Okay, so I'm looking right now. I know my perimeter formula is going to be P equals 2 times length plus 2 times width. So right now I'm looking, and I have a number of rectangles. For this first one, we have 1 rectangle. For the second one, we have 2 rectangles. For the third one, we have 3 rectangles. Okay, easy peasy. Got those all done. Next one, I'm going to find my perimeters here. I'm looking at my perimeter. I'm going to use this equation. I could also just count these up. If we're just going to count for the first one, I got 2 here, 2 here, 1, 2, 3, 4, 5, 6. We know our perimeter is a distance around. Our perimeter is going to be 6 here. I could also plug that in by doing our length is 1, our width is 2, so it'd be 2 times 1 plus 2 times 2, which is going to equal 4, 2 plus 4, which is 6. So that would kind of be your equation for that. Our next one, we're going to plug in 2. I could count that up again, or I could do my length and width. I'm going to do that. I see my length is 1, 2. My width is 1, 2. So we're going to have 2 times 2 plus 2 times 2, which is going to be 4 plus 4. And we're going to have 8 there. And for number 3, we're going to have a length of 3 here on the side, a width of 2. So we're going to do 2 times 3 plus 2 times 2. That's going to be 6 plus 4, which is going to be 10. Awesome. Finally, our ordered pairs. I'm just going to do 1, 6, x, y, always remember for those ordered pairs. 2, 8, 3, 10. And our table is completed right there. We got our table done. Awesome. Next up, it asks us to describe this relationship in words. Before I do that, I think I am going to actually move on to my equation here. And I know that my equation is going to be pretty simple here, because what I really have is I have my mx plus b is what I want to think about up here. And I'm going to look at my common difference. So my first thing that I'm going to figure out is the common difference here. I see plus 2. So So I know that my common difference is 2. That's that jump in between. Again, if you did not watch yesterday's lesson, I strongly recommend that. So I'm going to write that right down here. I'm going to start with y equals 2 times x. And finally, we have to figure out what that would be at 0 for this top one. Good examples of that yesterday. So I'm going to go back right here, 0. And I know the difference here is going to be plus 2. So this has to be a 4. So plus 4. And this would be my equation right here. I can check that out by plugging in an x and seeing if that'd be true of y. So let's plug in 4. If I plugged in 4 there, I would get 8. 2 times 4 is 8, plus 4 is going to be 14. And if we did 4, 2 plus 4 is 8, plus 4 is 12, excuse me. And if we had 4 right here, we'd go up plus 2 more, and we would get 12. So our equation checks out. All right, so we got our table. We have our equation. I'm going to graph this now. I'm kind of running out of room. I'm going to graph right here. And I remember my x is down here. My y is up here. And basically, I'm just going to graph all these ordered pairs right on my graph. So I'm going to go from, let's see, 1, 2, 3. Here we'll go 2, 4, 6, 8, 10. Okay, my first one is going to be at 1, 6. Second one is going to be at 2, 8. Third one is going to be at 3, 10. And I have my graph right here. And we know that this would carry on forever in both directions. Awesome. So now we got our table, we got our equation, we got our graph, and finally in words, I could say something like multiply our number of rectangles by 2, because we know we have 2x. Our number of rectangles is x. Multiply our rectangles, number of rectangles by 2, then add 4 to find the perimeter. And that would be a great way to do all that. I know that kind of sloppy. A lot of work for a problem. These are all going to be quite a bit of writing for each of these. But we have our table right here. I found those common differences to plug those into our y equals mx plus b. Again, watch that video from yesterday if you haven't. And then I made that formula with that. I found where it crossed at 0. I found common difference of plus 2. Plugged that all right in and was able to graph that using my ordered pairs. Perfect. All right, jumping ahead to number 5 here. They're asking us to, for each table, determine whether each relationship is a function. Remember our function rule. We'll talk about that in a second. Then represent the relationship using words, an equation, and a graph. Okay, so first thing, I have our function right here. I know for our functions, exactly one output for each input. Our inputs are y, our outputs are x's. So we just need to know that there is, for every x, has one and only one y. That's how I like to say those. Helps me remember it. So my first thing that I'm going to do is I'm going to look at number 5 and see if each x has one and only one y. This is, if we want to rewrite this, they have n and m, but it's the same thing. X and y. And I see 0 goes to just 1, 1 goes negative 2, 2 goes negative 5, 3 goes to negative 8. So right away I know this is a function. They all go to 1 and only 1. Perfect. Then represent the relationship using words, an equation, and a graph. So first thing that I want to do is I want to make a graph because I already have my ordered pairs here. I have my x's, I have my y's, and I see my y's go from 1 to negative 8. Ooh, I should probably make this a little different then. I didn't look at my negatives here. I'm going to write this like this. My x's are all positive, so I'm going to write this. I'm going to go 0, 1, 2, 3, and my y's, these are my x's, my y's go up and down, and I'm going to have 2, negative 4, negative 6, negative 8 is how we're going to do that. Start out by graphing these. X is 0, y is 1. There's a point right there. X is 1, y is negative 2. Okay. X is 2, y is negative 5. X is 3, y is negative 8. And there's my graph right here. I don't know if it's just a little curved or if that's mine yet, but we'll figure that out in a second. So my next step to do is to find an equation. Remember, we're going to use that equation that we were talking about before. We're using that y equals mx plus b. Knowing that this is our common difference, which we're going to find here in a second. And this is y at x0. So right away, I'm going to find that common difference by looking at these here. That's going to be a minus 3. This is going to be a minus 3. And this is going to be a minus 3. Okay, so I got minus 3. Y equals minus 3x plus, now I just have to figure out what it is at 0. They already told us here. It is 1. We got that right there. And we have our equation. We could test it out by plugging in. Let's plug it in with 1. 1 times negative 3 is negative 2, or negative 3, plus 1 is negative 2. Checks out. Our equation is set right here. We have our graph. We have our equation. And finally, in words, multiply x by negative 3 and add 1 to find y. Again, a little lengthy. These problems will take a bit. You might need another piece of paper, but that's the gist of it. Last one here, it tells us to graph each set. Graph a set of ordered pairs, determine whether the relationship is a linear function. Remember, linear, I like to think of that as line. Straight line. That's our cue to figure out if that is linear, if it moves in a straight line, and it will be able to explain pretty easily how we know that. So I'm going to start drawing a graph here. I see they're all positives, so I can just do my x here, my y here, and we're going to go from 0 to 3, 0, 1, 2, 3, and here we're going to go a little bit more, so we're going to go 2, 4, 6, 8. Okay, I got 0, 6 right here, 1, 4 right here, 2, 2 right here, and 3, 0 right here. And if I were to graph these, my graph isn't quite perfect, but these would be in a straight line if mine was. It's easier to tell in graph paper. But I know that each one is going down by 2. It's going over 1. It's moving the same direction. So it has a common difference that is always the same. Notice this is going minus 2, minus 2, minus 2, and this one is going plus 1, plus 1, plus 1. If those are all moving at the same pace, this is linear. I'll let you describe that on your own. I know that was a lot of work, a lot of talking for 3 problems, but I'm hoping that'll help you get started on this. If you have any questions, hop into my office hours. Otherwise, have a great day. Make sure you watch that lesson from yesterday before you jump into this too much. All right, bye.